Hello, my name is Mike and I'm the owner of MB IoT Network Solutions. If you're a company who wants to start your IoT journey, or you need some advice how to introduce IoT in your company, your products, or to your customers, you can contact me. I will help you. My contact information is at the end of the video. Let's talk today about what is a good IoT solution or IoT platform. I will give you a very high-fly 30,000-foot overview about what I think is a good IoT solution or platform. I will give you some insights of what I have encountered over the years. For the purpose of this video, I will oversimplify a lot of concepts to provide a frame of reference. These are the key features I think you need to look for in an IoT platform. It needs to support multiple protocols and data formats. It should not limit you in how the data is sent or in what format. The most common format to send data is JSON. There's an ongoing debate about JSON and HTTP too, but more about this in a later video. A good protocol support allows you to use low-powered, low-spec devices with communication. These devices are expected to run mostly on lithium-ion batteries for years, so a bulky protocol would not support this. The ability to scale up IoT grade. Millions of devices exchange millions of messages in near real time. This should be your goal. In 2018, Amazon sold over 100 million units of the Alexa worldwide. You can imagine the data amount, general amount of messages going through Amazon servers every minute. Security is the biggest roadblock for most IoT deployments, since the device might carry sensitive data. Any breach would be serious. We have to think not only about a possible breach of the cloud, we also have to think about the device itself and the protocol. Protocol breaches or man-in-the-middle attacks can be serious as well. The platform needs to provide X.509 certificates, cloud connection keys, or federated identities. A strong integration of the cloud with mobile apps and with, for example, machine learning, AI, and stream analytics is paramount. The user needs to be able to work with the data gathered to get the most value out of it. And finally, a good IoT platform needs to support SDKs and tools to allow the user application enhancements. A good platform should enable the user to connect devices securely, work with the data, and analyze the data seamlessly. The platform needs to provide some sort of IT gateway, which handles connectivity, provisioning, and security. It needs then to provide the incoming data to the needed cloud applications, like stream processing or data storage. Depending on the architecture and the need of the company to use their data in the cloud, the platform needs to be able to provide a clear structure and clear flow path so the user can quickly understand where data is coming from and where it flows. In our overview example, it flows from stream processing into data storage. This is one of the more common architectures. Cloud applications can now access the data. Data analytics can process long-term data and analyze pattern of behavior, for example, weather predictions, and so on. Machine learning can be trained, creating models, which then would be sent data to the application control application. The user would have a business logic application to send data to a mobile device, to notify a user, give feedback to a user, or just provide users with data and a visualization. A fitness tracker is a perfect example of this. They are gathering my fitness data, and later on I can log in and to a web page to see my data visualized. The business logic can also send data back to the application control, which is used to send data back to the IoT device gateway. In our example, to maybe control the sensor, set thresholds, calibrate the sensor, update the firmware, or in our fitness tracker example, to show me a newly awarded badge, congratulate me on a new achievement, or just vibrate to tell me you have made your 10,000 steps. Here we see the end-to-end value chain which our IoT platform should support. On the left, we have devices, sensors, and a gateway. The gateway then connects to the cloud, and the cloud has the ingestion, automate the data, send the data automated to where the data needs to be, big data and data analytics, and then at the end, the report and the act. I have seen and worked on several cloud platforms which did not support the automate, big data, and act or report part. These clouds were only purposed to support ingestion, storage, and visualization. Stream analytics, data analytics, ML, AI were not possible on these platforms because they were lacking the ability to process the data stream itself. When you look for a cloud platform for your project, you need to make sure the platform you're looking for is actually providing these features. Switching cloud platforms is very costly and, depending on your device, sometimes technically difficult. Gateways have certain responsibilities. In my opinion, they're the most important part of an IoT cloud platform. You have activation security, configuration management, and health monitoring, which is group 1. Then in group 2, you have remote configuration and over-the-air updates and command processing, for example, restarting your device. In group number 3, you have buffering and reliability, filtering and aggregation, and where it makes sense, extensibility. The IoT message communication, which comes from the device and going into the gateway. MQTT is the most popular broker for IoT. AMQP as well. And if you have a very low spec, low level device, sometimes you have to work with HTTPS. Messages are sent and received via MQTT are minimizing the code footprint on the device and reduces network bandwidth. You can run MQTT and AMQP through their assigned ports 1883 and 5671, or you can send them via WebSocket. Overall, the IoT platform must be designed to support millions of devices and billions of messages. Cisco once estimated that every second 125 devices are connected to the internet. The gateway is responsible for cloud authentication. The most common ways of authentication are X.509 certificates, cloud keys, any cloud provider specific system, for example Amazon Incognito, or federated identities. Basically, every device can become an IoT device or smart device and send data to a gateway or directly to the cloud. This starts with an ESP32 type boards, goes to Raspberry Pis and Arduino boards, or more powerful computers which would be used as IoT gateways. It is pretty simple to connect an ESP32 chip to the cloud using MQTT and cloud keys. Even OTA is possible with these small and very cheap chips. When it comes to higher performing hardware, if the device can run Linux or Windows, it will serve very well as IoT device or IoT gateway on-prem. The ideal platform should support a large variety of SDKs and languages. It should not limit you to a certain type of device or language. The most common ones is a C SDK, which is ideal for embedded OS, Java SDKs or JavaScript SDKs, which is ideal for Linux platforms, an Arduino library, which can be run on any Arduino-based chip, and mobile SDKs for Android and OS. At the end of this presentation, let's talk about an example. In the past, Alaska DOT only had a road weather information system that had fixed sites which collected weather information like pavement sensors, atmospheric sensors like temperature, humidity, atmospheric pressures, and CCTV cameras. This system had a big disadvantage: its fixed locations. 33 locations can only give a snapshot of the weather conditions and are very hard to maintain. What Alaska DOT did, they mounted 2 sensor arrays on their light to medium truck fleet. These sensors were looking for the road data and for the sky data. Basically, they were measuring temperature of the road, the condition of the road. They were also measuring the temperature, the humidity, and the atmospheric pressure while driving through Alaska. All this is sent via cell phone through the cloud. They call it weather cloud. Within the weather cloud, it goes to stream processing, into the machine learning models. Data analytics is doing their part, and the application control is then controlling back or giving back the information to the operator if de-icing salt should be on the road or not. The prediction models provide an accurate 72-hour forecast, so the data-driven decision can be made to ice treat a street ahead of a storm or not. This saves Alaska DOT millions of dollars a year. It also has decreased the weather-related car accidents by nearly 80%. Thank you for watching. My name is Mike. I'm the owner of MB IoT Solutions. If you have any questions or are in need of IoT consulting, please feel free to contact me. You can do this by sending me an email or connecting with me on LinkedIn. Please sign up for my YouTube channel so you don't miss any new content.